Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Complex numbers. The topic is modulus and argument. But in this lecture, I will discuss argument only, as I already have discussed modulus in my last lecture. You can find the link of the math website in the description where you can find the soft copy of this lecture. An important advice: we should be polite to others. Argument. It is the angle made between the positive real axis and the position vector. The argument of a complex number x plus iy is the direction of the position vector from positive real axis. If this is z, x plus iy, then this angle is the argument of this complex number, and it is written as argument z theta. This is the standard way of writing argument. The domain of the argument. The principal argument theta of a complex number is an angle such that this is the standard domain of complex number. In radians, theta lies between minus pi exclusive and pi inclusive, whereas in degrees, theta lies between minus 180 exclusive and 180 inclusive. This means that work in anti-clockwise direction for complex numbers which lie in first and second quadrants, and this means work in clockwise direction for the complex numbers which lie in third and fourth quadrants. We can understand this domain through these two sketches. We can split this domain into these two domains, minus 180 to 0 and 0 to 180. This means work in clockwise direction till here. So for complex numbers lie here, here and here, you have to work in clockwise direction. And for complex numbers which lie here and here, you have to work in anti-clockwise direction. This is the meaning of this domain, and this is the meaning of this domain. One very important thing regarding the argument. The argument's line is always a half line that is never extended in the opposite quadrant. For example, if we have to find argument of this complex number, then never extend this line into this quadrant. This is the wrong way because we extended this line wrongly here. And this is the right way. See, this is the right way. Don't extend this line here. So this is the right way and this is the wrong way. Well, since the equation of this line is y is equal to x, so we can easily find its argument. The argument is 45 or pi by 4 in radians. The notation of the argument. The argument of z is argument z. It is written as argz. Use trigonometry to find the argument. The basic angle alpha. We have done this in trigonometry that basic angle alpha lies between 0 and 90 exclusive, and its formula is tan inverse y upon x. One very important thing, the diagram must be drawn first to check the position of the complex number. So while working for the argument of any complex number, make sure you first sketch the rough diagram. You first sketch the complex number on Argand diagram. We can understand this thing through this example or this example. Now the question is, find the argument of this complex number. So first sketch this number. This plus 5 means 5 units to the right, and this plus 12 means 12 units to the up. So 5 and 12. So this number is here and its argument is here. So find alpha. Alpha is tan inverse 12 upon 5, it's 67.4, and this is the argument of this complex number, because in first quadrant theta is alpha. Write your answer up to 1 decimal place. Example 2. We have to find argument of this complex number. So first sketch it. Minus 3 means 3 units left, and 4 means 4 units up. 4i means 4 units up. So minus 3 is here and 4 is here. This is the rough sketch. So this complex number is here. So its argument should be this, theta, this angle, and this is 180 minus alpha. So first work for alpha. So alpha is tan inverse y upon x. Never take negative sign for alpha. Alpha is 53.1301. Therefore argument of this complex number is 126.9 up to 1 decimal place. Now we have to find argument of this complex number. Minus 2 means 2 units left, and 2i means 2 units up. So this is here. This is 2. So this is the argument. Since both the numerical values of real part and imaginary parts are same, 2 is equal to 2, therefore the equation of this line is y is equal to minus x. Hence its argument must be 135, because this angle is 45. So if both the real and imaginary parts are same, then the equation will be either y is equal to x or y is equal to minus x. In this case, since x is negative, so the equation is y is equal to minus x. You can easily differentiate the equation if you sketch the complex number correctly on Argand diagram. So this is the way to find argument of complex numbers. Few more examples. Now we have to find argument of this complex number. This is the now first sketch it. 1 plus 1i, that means 1 unit right and 1 unit up. So 1, 1. So this is 1 plus I. Since both the real numerical values of real and imaginary parts are same, so the equation of this line should be y is equal to x. So its argument should be 45. The argument of this complex number should be 45 in degrees. 1 minus I. 1 minus I means 1 minus 1i. So 1 unit left and 1 unit down. I'm sorry. 1 minus 1i means 1 unit right and 1 unit down. This is here. One unit right and 1 unit down. So this the equation of this line is y is equal to minus x, because of the same numerical values of real and imaginary parts. So this angle must be minus 45. So argument of this complex number must be negative 45. So when the numerical values of real and imaginary parts are same, you just need to identify the right equation. The equation could be either y is equal to x or y is equal to minus x. In this case, the equation is y is equal to minus x, whereas in this case, the equation was y is equal to x. minus 3i. Again we have same numerical values of real and imaginary parts. So we need first sketch this complex number on Argand diagram. Minus 3 means 3 units left and minus 3i means 3 units down. So here is the complex number. So the equation of this line is y is equal to x. And this is the basic angle 45. But the argument is minus 135 according to the domain of the argument. I told you when complex number is in third quadrant, then work in clockwise direction. This is the argument of z, minus 135. These are two equations, y is equal to x and y is equal to minus x. So if complex number lies here, then the angle should be 45, argument should be 45, and if the complex number is here, the angle should be minus 135. You can understand this concept here. These are the examples. 2 plus 2i. See, 2 plus 2i is in first quadrant. And the equation of this line is y is equal to x. So the argument of this complex number is 45. Minus 2i is here. And this is the equation of y is equal to x. So its argument must be minus 135. Minus 2 plus 2i. The equation is y is equal to minus x. So the argument is 135. And this is in fourth quadrant with equation y is equal to minus x. So angle is minus 45. These two complex numbers lie on y is equal to x, whereas these two numbers lie on y is equal to minus x. Sketch is compulsory for argument. This is y is equal to x. This is in real numbers, not in complex numbers. 2, 2. Same values, x, y. So y is equal to x. 45 minus 135. This is y is equal to minus x. This angle is 135 and this angle is minus 45. Another example, z is equal to 3i. First sketch it. 3i is here. Well, just write 3, don't write 3i. So this is 3. So this, the argument of this complex number is 90 degrees or pi by 2 in radians. Minus 3i, this lies here. So its argument must be minus 90. Well, argument z means the angle of z from origin. We can write argument z as argument z minus origin. This is one of the most important thing in argument. Must understand the meaning of this thing. This means the argument of z from origin. And you can write this as z minus origin. This is here. The angle of z must be from origin. If the question is draw this line, argument z 45. The formal term is draw the locus of z if z is this. But since we haven't discussed locus in complex number yet, so just understand this, draw the line of this argument. We will discuss this in loci. So since this is 45, so the equation of this line, argument z, must be y is equal to x. And this means the angle of z from origin. We just have z here, so we can write this here z minus 0 in this way as well. So whenever it says argument z, it means argument z minus origin. So the angle of z should be from origin. This is the meaning of argument z. What if we have a different thing, like argument z minus u? This means angle of z from origin, whereas this means angle of z from u. I mean, you have to find argument of z from u, and u must be given. This is u, for example, and we have to sketch this line. We have to sketch the line of z. So first we have to sketch u. This is u, minus 1 plus I. Minus 1 plus I. So first sketch u correctly and then draw 45 degrees from u. And you know how to draw 45? 45 means y is equal to x. And for that you just need to go same units on x direction and same units on y direction. So to draw y is equal to x, we have to go 1 unit right and 1 unit up. This is the way to sketch y is equal to x. This is the line. This is the line of argument z. And this angle is 45. Make sure you always sketch 45 correctly. Same units right and same units up. This means y is equal to x. And this intercept must be 2. You have to mention this in exam. And z lies on this line, anywhere on this line. And this is the line of argument z. And this angle is argument z minus u. This means argument z minus u. So let me summarize this concept. This is one of the most important concepts in argument, and this concept will help you to sketch the Argand diagram of different loci of z. So argument z means the angle of z from origin. That means you can write argument z as argument z minus origin. So if you have to sketch argument z 45, then you understand that you have to find angle of z from origin. I mean, this is the angle of z from origin. This means argument z from origin, whereas this means argument of z from u, and u is given. So first sketch u. This is u. Minus 1 left. Minus 1 means 1 unit left from origin, and 1i means 1 unit up. So this is u. Now make 45 degrees from u. First draw a horizontal line and then 45. And how to draw 45? To draw 45, you have to go same units to the right and same units to the up. You are going 1 unit right, so you have to go 1 unit up. And you have to mention this intercept clearly and correctly, that this is 2. This line cuts the imaginary axis at 2. And this angle means argument z minus u, means argument of z from u is 45. And minus sign is the standard sign. Another example. See, to shade the region where this z lies, we have to understand this thing. This means argument of z from minus 2, because we must have negative sign here. The sign must be negative between z and u. This is the standard sign. So since we have positive signs, so we have to simplify this in this way. This sign must be negative. Now it is negative. So this means the angle of z from minus 2, and it should be 45. So first you have to draw minus 2. This is minus 2. And this angle is 45. And I told you To draw 45, go same units right and same units up. You are going 2 units right, so you have to go 2 units up. So this is the 45-degree line. Since Z lies between 0 and 45, so you have to shade this region. This is the required region. Make sure you understand this concept. This sign must be negative. This is here. If we have Z plus U, then make this sign negative in this way. Minus, minus. So if we have this positive sign here, then make sure you have you should convert this line into negative sign carefully. And this must be in bracket. This U must be in bracket like this. Well, the next topic is the modulus and argument of Z and Z static. We have discussed Z static in the second lecture of complex numbers. Z static is the reflection of Z in the real axis. If this is Z, x plus iy, and it's here, then Z static must be in this quadrant, fourth quadrant, because the reflection of Z about real axis should be here. This is the reflection of Z about real axis. The modulus of both the complex numbers are same. Both lengths are same. And the numerical values of arguments are same as well. If theta is 45, then this is also 45, but the direction is opposite. This is positive theta and this is negative theta. Because in fourth quadrant we work in clockwise direction. So if the angle of this complex number is 45, the angle of this must be minus 45. With respect to this diagram, we can say that modulus of both should be same and argument of Z static should be negative times argument Z. You must remember these two facts regarding conjugates. Now let's understand this concept through this example. This is Z and this is Z static. First sketch Z. Z is in fourth quadrant here. And the equation of this line is y is equal to minus x. So this angle must be negative 45. And the modulus of this complex number is 2 root 2. Now the modulus of Z static must be 2 root 2. And the argument of Z static must be 45 only, according to these two results and according to this sketch. Properties of argument. You can learn these properties through the examples of laws of Allen. These properties are similar to the laws of Allen. This is the property number 1. You know, you have done in logarithm, in laws of logarithm, that if we have ln a power b, we can write this as b times ln a. Same is here. We can bring this power here. We can make the power coefficient of argument. So this property is similar to the power law of Allen. And this property is similar to the product law of Allen. Ln AB. We write this as ln A plus ln B. In argument, we write this as ln argument U plus argument V. And this is similar to quotient law of Allen. Ln A minus ln B. So we can simplify this as argument U minus argument V. So these properties are similar to the laws of Allen. While using the above properties, these properties of argument, if the argument is out of the domain, for example, if you get anything outside this domain, then make a rough sketch to identify the quadrant of the complex number and get the required argument and correct argument. This is very important. Let me repeat this. While using these properties of argument, if the argument is outside the domain, then make a rough sketch to identify the quadrant of the complex number and then get the required argument and correct argument. We can understand this concept through these examples. Given argument u is 135 and argument v is minus 60. And we have to find argument u cube, argument uv and argument u upon v. So according to property number 1, we can find argument u cube. So this 3 will come here. We have argument u, it's 135. So 3 times 135 makes 405. Since this angle is outside the domain of the standard argument, this is the standard domain of the argument, and this angle is outside from that domain, so we have to sketch this 405, and this is in first quadrant. 405 is here, so the basic angle should be 45. Since 405 exceeds 180, so make a rough sketch to identify the quadrant of u cube and hence get the required argument. So the required argument is this, which is 45. This total angle is 405. Till here is 360. So this small angle is 45. So the required argument of this complex number is 45. This is the meaning of this concept. If argument is outside the domain, this domain, then make a rough sketch to identify the position of the complex number and get the required argument. Next, argument uv. So according to property number 2, we can easily find this argument. So argument u plus argument v. This is 135, this is minus 60, 75. Since 75 is within this domain, so this answer is perfectly fine. You don't need to change this argument. The next one. Argument u upon v. We can write this as argument u minus argument v according to property number 3. This is 135 and this is negative 60, so answer is 195, and this answer is outside from this standard domain of the argument. So we have to sketch this complex, this 195 thing. So 195 is here, see. And according to this domain, we cannot go in third quadrant. The limit is till here, till the end of second quadrant. This small angle is 15 degrees because till here is 180. Since this complex number is in third quadrant, so according to this domain of argument, which is the standard domain, we have to work in clockwise direction. I told you, according to this domain, if complex number lies in third quadrant, we work in a clockwise direction. So the required angle is minus 165. I've mentioned this thing here. Since 195 is out of the domain, so make a rough sketch to identify the position of this complex number. This complex number is in third quadrant. Since u upon v is in third quadrant, so work in clockwise direction to get the required argument, which is minus 165. So make sure while using the properties of argument, if the answer is outside the domain of the standard domain of the argument, then always make a rough sketch to identify the position of the complex number, like in this case, and get the required argument. If complex number lies in first and second quadrant, then work in anti-clockwise direction. Whereas if complex number lies in third quadrant or fourth quadrant, then work in clockwise direction. This is one of the most important concepts in argument. This is the past paper question. we need modulus and argument of this complex number first, and then we have to find these, this and this. So part 1 first, we need modulus and argument. See, we have done modulus in last lecture. The formula of modulus is x square plus y square. So this is x, so under root 3 square will become 3, and the coefficient of I is 1, so 1 square is 1, so the answer is 2. For argument, we have to sketch the rough sketch of the complex number. Under root 3 is here and 1 is here. This is z is equal to under root 3 plus I. So this is the argument of the complex number z. So alpha is tan inverse root 3 upon 1, which is I guess pi by 3. I'm sorry, this is 1 upon root 3, y upon x. So it should be pi by 6. So argument of z is pi by 6. Check this solution. This is the modulus and this is the argument. Here is the fair solution. The complex number z here, modulus is 2, argument is pi by 6. The second part of this question, we need to find this complex number 2z plus z steric. You all know z steric is the conjugate of z. So 2z plus z steric. 2z and z steric is the conjugate of z. For conjugate, just change the sign of I. You just need to simplify this. Just collect the like terms. So the answer is 3 root 3 plus I. Now the next part of this question is we have to find this complex number I z steric upon z. This is very simple. This is I and this is z steric and this is z. You have to rationalize this complex number. So you need to multiply this whole fraction, multiply and divide this whole fraction with this denominator's expression and opposite sign, like root 3 minus I, root 3 minus I. This is here. Multiply and divide this fraction by the denominator's expression with opposite sign. We have done this in detail in, I think, first lecture and second lecture. So this is here, a square minus b square. Just simplify this numerator and break the LCM because you have to give your answer in this form. So this is the complex number. And this number is in first quadrant because both parts are positive. And its argument is tan inverse y upon x, which is pi by 6. Check the solution again. So this is the second, I think 2 part B. Now this part is very important. On a sketch of an argon diagram with origin O, show the points A and B representing the complex number z and I z steric, and show that AOB is pi by 6. So you have to sketch z and I z steric on the argon diagram. Well, this is I z steric. You have to sketch this and this. Here is the sketch. This is root 3 plus I. This is the estimation. Root 3 is approximately 1.7. And this is 1 plus root 3I. So we need this angle. We have to prove this angle. This angle. And this angle should be argument B minus argument A. This angle is argument B minus argument A. But you don't need to find this angle through this method, like calculation method. You have to use properties. Of course, you will use this thing argument b minus argument a, but you will not find individual arguments of these complex numbers. You have to use property of argument. See, AOB. This angle is argument b minus argument a. And b means IZ static and a means z. Now use the property. This is what I was saying. Do use this property of argument. Argument u minus argument v is equal to argument u upon v. Like this. And then state the answer of this, which you did in the last part. The answer of this is pi by 6. This is here. So this is the way of using the properties of argument. This is just one way, but very important way. You must be good at these types of questions. I hope this lecture will help you to understand the concepts of argument well. Inshallah, I will discuss modulus argument form, this thing, the R theta form in my next lecture, inshallah. Good luck. Allah Hafiz.